I'm going to annotate here. So in the triangle above, if theta decreases at a rate of 3 radians per minute, at what rate is y increasing at per minute? So when x is 4, y is something, right? So what is that value? So first, if I want to find the rate at which y is changing with respect to x and looking at theta, I have several ways of doing this. I have a triangle. So this should come back from your trig days, okay? What trig function, okay, associates x and y? Is it sine, cosine, or tangent?
Tangent.
Tangent, correct. So then we start off with your tangent function. Tangent of the angle is equal to x divided by y. So that is your equation that you start off with. Now, what are we doing? We're doing applications of derivatives. So that means I must take a derivative of this equation. So we all know the derivative of tangent is going to be secant squared theta equal to, now one thing I forgot to write, it says that theta is decreasing at a rate of 3 radians per second. So you know what I need to write after that? D theta dt equal to, now I have this function right here, right? It's changing per minute. So that, guess what? I have a function x that's changing over a function y that's changing. So what rule do I need to use to take a derivative of this part of the problem? Everyone forgot?
Quotient.
Thank you, quotient rule. So remember that we do a quotient rule. This is going to say y times x, or actually not x, but let me clear this. But well, I can do x prime for this moment right now, plus y prime x over y squared. But now, when I look at this, what is x prime and y prime? I'm taking derivative of those two functions, right? So this is actually going to be, can anyone tell me what the derivative of x is with respect to t going to be?
dx over dt.
That's correct. Dx over dt is for this one. So therefore the y should read as what?
dy over dt.
That's right, dy over dt. So you're going to replace those two with this. Now you say to yourself, okay, great. Now I start filling in some, like, you know, some things here. I have to take a look at, okay, well, what's my angle? What's my, I know my x is 4, right? X is 4, but what's y? And what is my angle? Well, how do I figure that out? Well, we do know one thing. We can figure this triangle out by using Pythagorean's theorem, right? Because it's a right triangle. So if this guy is 4, and I kind of give you a hint, this is like one of those special triangles. So what do you think y is going to be? Can you remember? Nope. 3. Exactly. These are one of your special triangles. One of them is 5, 12, 5, 12, 13. 3, 4, 5 is the other one. So 3 squared is 9, 4 squared is 16. You add them together, you get 25. And when you want to figure out the hypotenuse, you square root that, you get 5. So this is one. So you're going to get like special triangles. Like you don't really need a calculator to do this. So if I have this, the only calculator part you need to know is what is the angle at that moment, right? At this part, well, how big is that angle? So you're going to have to do the tangent 4 over 3, or you do. You can do cosine of 3 over 5 or sine of 4 over 5. Does it make sense? So that's where you have to use a calculator to figure out what the angle measurement will be. And it has to be in radians. Okay, so make sure it's in radians, not degrees. So it'll screw you up. So that's about it for that part. if I move on, here's another one too. 10-foot ladder is leaning across against a house on a flat ground. The base of the ladder starts to slide away. You can see by the picture, right? So as the base of the ladder is sliding away to the right, the top of the ladder is sliding down along the house. So when the base has slid 8 feet from the house, it is moving horizontally at a rate of 2 feet per second at that moment. So it's asking how fast is the top of the ladder sliding down the wall at when the base of the ladder is 8 feet from the side of the house. So this is 8 feet from the side of the house. It's moving at 2 feet per second horizontally. So that's in the X direction. It wants to know how fast it's dropping in the Y direction. Looking at this diagram, obviously you notice there's no equation here written for you, right? But we have to develop an equation. What would be an equation that associates the X and the Y axis, or the X and the Y legs, with this ladder? What does it look like to you?
A right triangle.
A right triangle. So if it's a right triangle, what formula do we use to figure out the legs of a right triangle? Given if you were given the hypotenuse, or you were given the leg, one of the legs. What
A
formula
squared plus b squared equals c squared.
exactly, which is called what? Touch the letter P?
Pythagorean theorem.
Pythagorean's theorem. Instead of using A, B, and C, what are we going to use? We're going to use X plus Y squared. X and Y for your legs. So X plus Y squared. So instead of C squared, we can call it, they usually call it R squared, right? Because that's usually, how do we develop Pythagorean's theorem? Came from a unit circle. So when you look at X and Y instead of a circle, he was able to look at those points away from secant lines to radius lines inside of a circle. So he used R squared instead. R meaning the ladder length in this situation. So we know where X is. X is 8 because it says it's sliding from the house, the base. So this is the base right here. So this has got to be X. We just don't know what Y is, and we don't know dy dt. So we don't know dy dt, and we don't know how high it is above the ground when this guy is at 8 feet, especially when it's moving across this fast at that moment. Notice that the ladder length is always going to be fixed. So in this case, we've got our formula and we are differentiating it. Again, taking the derivative of this function. And real quick, in the review, what are we differentiating this function with respect to? Is it X, Y, R, or time?
Y.
Thank you, Colton. It's for time. So every time we take a derivative of this equation, right, it's probably gonna read what? 2x plus 2y equals 2r. But what are we gonna write after it? dx dt, then dy dt, then dr dt. After we take the derivative, right? And then we're gonna actually figure out what we got there, okay? Now, here's one of the things here though. I did say dr dt, I'm saying it as a general statement, but remember when we first started learning this application, we said some things are going to be held constant. Now, I want to ask you, does the ladder length ever change? No.
No.
So it means this guy will become a constant, which means it will just be 10 squared, correct? So that becomes a constant. So that means, guess what? That's less derivative work I have to worry about, because we all know the derivative of a constant is what? Not the same.
0.
0. So when we get that away, right? We like zeros in our work because adding zeros and dividing and multiplying by zeros are always nice. You already know what the answer is going to be, right? So that helps to get rid of our work. And so that means we really have a relationship that's going to equalize between these two. That's going to show the relationship between those two, which should, because it's telling me that if my base length is moving away from the height, from the side of the house, then it's affecting my height, right? As it moves, it's moving this way, it should affect that. So they're connected. We just want to see how fast it's actually dropping, okay? So we know when we take a derivative of this equation, it'll just be 2x dx dt plus 2y dy dt equal to 0. And then you have that. And if you end up with a negative number, you should, because why? Isn't this ladder falling down? So that means negative is also a what? Dropping direction, right? It's in physics. We always drop. We use negative signs as in the direction of going down or to the left. Okay, so I'm going to go ahead and that should be it for that part there. I'm going back to number 6. This should be fairly easy to do. Remember that normal lines are perpendicular slopes. So you find the slope first from dy dx, plugging in the point, and then what do? You flip it upside down and make it and take the negative of that value. Now remember this part. This is from kind of like maybe about almost 2 weeks ago. It says where the line tangent the curve is vertical. Which part of the derivative do we set equal to 0 and to solve? Is it the numerator or the denominator for verticals? Tangents, should say. Do any of you remember that? I'd like to guess. I'll just write it out real quick. Just remember and just give you an example. If I have a function on top and a function on the bottom, these are my derivatives now, f prime, g prime. Which part of this function, rational function, will I set equal to 0 to solve, to find vertical tangents?
Denominator?
Thank you very much. So you're gonna take this guy, the denominator. I'm showing a representation of it because it should be a derivative at that moment, right? Set that equal to 0 and start solving, okay? So you're gonna find the coordinates. That means find both x and y. So at a moment right now, you're gonna have a plane function, and what you're gonna do is you're gonna have substitutions, like y is gonna equal to x, or you're gonna have x equal to y, some sort of function. And what are you gonna do? You're gonna plug it back into here, okay? And you're gonna figure out what your function is, all right? So what that means is we're gonna set this whole thing equal to 0 and figure out what the function is supposed to be, okay? Let me make sure. Let me pause for a moment. Resume. Please write this on your paper when you're at home. Set this. This is set equal to 0 because originally it should have been this whole function equal to 6, but instead I subtracted it and forgot to do that. Okay. So do that. Set it equal to 0. That should help you to find your first coordinate point, and then when you find that, you plug in your values in for either x or y, and you find your other numerical point. Okay. So first you got to find dy dx. Okay, and then set the denominator equal to 0. Then make proper substitutions. Solve for either one. Solve for either x or y. Then plug it back into the original equation. And then you're going to have a function that's either going to have all x's or all y's, and then you can easily solve for your equation. Okay? All right. So I'm going to go ahead